All right, so let's talk a little bit about some things that we'll need for the next lab, some that can use a little bit in this one. So we're going to look at a completely different uh, program that we haven't talked anything at all about. Does anyone know the rules on determining whether or not a year is a leap year?
If it's divisible by 4.
Okay, a leap year has to be divisible by 4. But not by 100. Unless, does anyone know the other condition? Do you? All right, so what does that mean? The year has to be divisible by 4 first. If it's divisible by 4, but then divisible by 100, so what kind of years are divisible by 4 and are divisible by 100? So for instance, is 1900 divisible by 4?
Yeah.
Yeah. But it's divisible by 100, so this rule kicks in. Is it divisible by 400? No. So 1900, not a leap year. You had a question? Okay, I thought I saw a hand a second ago. What about the year 2000? It's divisible by 4. It is divisible by 100, so we're questioning it for just a second, but divisible by 400 makes it okay. And so this was a leap year. Does that make sense? All right, so what we're going to do is we are going to try to write a program that will take input from a user of a year, and then will output whether that year was a leap year or not. Okay? So all right, so let's see, what do we have to do first of all? First of all, we want to try to get input from the user. And so input from the user, you can do this either in the interactive shell, or we can do this in a new file. Probably better in a new file so that we can run it and make changes and go back and forth and just type things one time. So we want to get some input from a user. So we want the user to tell us a year. And so the idea here is, let's say we ask the user for a year that we're going to save in a variable called year. Now, some of you have already looked ahead into, I think it's chapter 7 in the text. Some of you have seen Python's way of getting input before. But the way to get input in Python is with the word input. Input is a function. So we have the parentheses. And what we put here is the prompt of what you would like to have. All right, so we could say maybe enter a year.
Is that a space between the colon and the...
I put a space right here between the colon and the quotes because whatever you put here is what shows up on the screen, and when you start typing the year, there will be a space. If you don't put a space, then the year that you start typing will be right up next to the colon. And so that's usually when you want someone to enter something, it's nice to make it look like it's over to the side, and that space will do that. You can do that or not, as you choose. Yes. So, but I put the space there. Okay, so what's going to happen? We enter a year, and so the prompt on the screen will say enter a year. The user types in a number, and we have a year in place. Now, what happens if the user types in their name instead? Input won't tell you that. It won't stop you from doing that, right? Input will just give the prompt, and whatever you put in there, it saves it. As a matter of fact, input takes whatever you give it and saves it as a string. So input is not really, even if you say enter a year and you enter something that looks like a number, it's actually saving it as a string. We want to do a calculation with this.
So change it from a string.
Sorry?
We'll need to change it from a string afterwards.
Yeah, so if we want this to be a number, we have to turn it into a number. And so a way to do that is we can change the data type. And in Python, to go from a string to a number, we can just type int year, and that will turn that string into a number. Now, if we don't want to turn it into a number, then we don't do this, right? We just leave it like it was, and it will be a string. But if we do this, this will turn that variable into an integer. If we want to turn something into something else, like a float, we can do that as well. Now, what happens if somebody puts in their name instead of a year? This part will probably break, right? Because this is not, you can't turn your name into a number directly. And so that would be, that would break. We would get Python would yell at us in red, and that would be the, something we would have to deal with later. So we're not going to deal with the user doing something completely wrong, right? We're just going to deal with the user following instructions and putting in a year. Now, what do we probably want? Well, in that calculation, we actually want the year to be 4 digits. So again, if the user was going to do something wrong, we would probably have to check this to make sure that it's a 4-digit number. The formula idea that we came up with, or what the rules are, actually only really works for years after 1752, because there was a calendar change in 1752, so we could really check to make sure it was the appropriate years. And so, but anyway, we're not going to worry about all of that. It doesn't work for BCE kind of things. It only works, again, afterwards. So all of that, we can make the program better and better and better. But right now, all we're doing is getting some input from the user, turning it into something that we can utilize. Okay, so we want to take this year that we've been given and try to figure out whether it corresponds to a leap year. We need to check to see if the number, whether it fits those rules. Is it divisible by 4? Is it divisible by 100? Is it divisible by 400 appropriately? All right, so what's the best order for figuring out what's going to happen? That maybe we assign each year a status. We say that it's a leap year, or the other type of years, all the other years are called common years. All right, so given a particular year, it's either going to be a leap year or a common year. So we could assign a status that maybe we just start off with an empty string. Again, this is not entirely necessary, but we're going to do some other things with this, and so we'll create it here. Excuse me. We're going to assign the value as we go through, so we don't really need to create the empty string in what we're getting ready to do, but sometimes we will need to have something created ahead of time. All right, so what are we going to do? We want to see whether the year is a leap year or not. So how's an easy way to tell that it's not a leap year?
It's not divisible by
It's not divisible by 4, right? If the year is not divisible by 4, we know right away that it's not a leap year. So we could have a conditional statement that says if the year is not divisible by 4, but how do we say not divisible by 4? Yeah, we use the modulus, right? So if year, we use the modulus. So if we divide that by 4, and we don't get 0, what do we want to change the status to? It's a common year, right? Okay. Now, what if it is divisible by 4? Then what are we looking at? Right, so if this didn't happen, we're into a next category. When do we want to make this a leap year? If it's not divisible by 100, then we have a leap year. Right?
Unless it's divisible by 4.
Well, unless, right? Okay, so what's going to happen? What if, well, if it's not divisible by 100, can it be divisible by, if it's not divisible by 100, can it be divisible by 400? No, right? So what happens if the year is not divisible by 100? If the year is not divisible by 100, what do we automatically know about it?
Not divisible by 5.
So it is divisible by 4 and not divisible by 100, so it is a leap year. All right. So what if it passes this test? So that means that it skips this test, right? If it skips this test, it is divisible by 4. It skips this test, so it's not divisible by, no, excuse me, back this up. We're going to skip this test. So we want something that is not this condition. So we have a number that is divisible by 4. Then what? We're skipping this condition, so it is divisible by 100. What's the next situation? What if it is divisible by 4 and is divisible by 100, but then is not divisible by 400? It's a common year, right? Does that make any sense? So what do we have? If we've gotten to this point, we were divisible by 4, we were divisible by 100, and we're saying, is it going to be a leap year. So if we are divisible by 4 and divisible by 100, what's the next check? We have to see, is it also divisible by 400? If it is not divisible by 400, but it is divisible by 100, that puts us into the common year, like 1900, right? It's divisible by 100, but not by 400. So that's a common year. What's the last condition, or the last situation? All right, how would we have gotten down to here? So we got through here, which means it was divisible by 4. We got through here, which means it was divisible by 100. We got past here, which means it was also divisible by 400.
And it's a leap year.
And so that is a leap year. Does that make sense? Yeah, no, sort of, maybe. So let's check a year. Somebody give me a number. Give me a year. What year were you born, Patrick?
2001.
2001. All right, so let's look at 2001. Is this year divisible by 4? So if we do year, divide that by 4, the remainder in that case is not 0. And so we're in this situation, and what do we have? We have this is a common year. Make sense? Let's do the test on the year 2000. We just said that 2000 was a leap year, so let's test it. If you divide by 4, do you not get 0? No, you do get 0. So we skip that. When you divide by 100, what do you get as a remainder? 0, so we skip that. You divide by 400, what do you get as a remainder? 0, we skip that, and we say that 2000 is a leap year. Okay? So this ordering of the conditional statements will get to the answer. Are there different orderings of the conditional statements that we could use to get to the right answer? Sure. But what does this ordering do? Let's just check one thing, and then if that doesn't hold, then the next check and the next check and so on. What are we in this status down here? This is just looking at the years that end in 00 that are also divisible by 400. This is looking at the years that end in 00 that aren't divisible by 400. This is looking at the years that do not end in 00, but that are already divisible by 4. So the ones that are not divisible by 4 are common years. If they are divisible by 4 and do not end in 00, they're leap years. If they end in 00 but are not divisible by 400, then they're common. But if they end in 00 and are divisible by 400, then they are leap years. Okay, so how could we use this? We could then take this and we could have a print statement, right? We could, down below here, we could print something like say something like that. This particular year was a leap year or a common year. Except what happens if we put in a future year? Then it would still say, 2040 was a leap year. So what could we do? We could add extra tests to say, is it in the future, is it in the past, right? And say was or will be appropriately. All right, but that's the same kind of idea. All right, so does this sort of make sense? Right, we have this repeated testing of conditions. But what happens? We need to order the conditions in the right way in order to get the kind of result that we would like to have. Okay, now, up here, what happens if the person doesn't give us a year? If they just keep hitting enter or doing something that doesn't work, we could force them to keep trying until they give us an actual year. So we're just going to force them to enter something until at least they've entered something, right? We won't focus on that, the fact that it's a year. Okay, that's not working. So I'm going to move this over for a second. We'll see what I'm getting ready to do. We want to put see what I can get here. All right, so I'm going to shift this over. We're going to tab this over because we're going to put this inside of a loop. We want the user to be forced to enter a year. So above here, line back up at the left, I'm again going to create an empty string. It's going to be the place to check for the year. We're not necessarily enforcing that it's a year right now. We're just enforcing that they put in something. All right, so this is a new kind of loop that we can use. Again, some of you have looked ahead and seen this loop. This is called a while loop. A while loop, rather than being a counted loop, is a loop that's based on some condition. Okay, so we want the condition when do we want to keep asking them for a year? Until they enter something. So what have they entered so far? Nothing. The string is empty. And so while that string is empty, what do we want to keep doing? We want to keep repeating. So when do we want to stop? We want to stop when it's no longer empty, right? We want to continue asking for them to enter a year, enter a year, enter a year until they actually do that. So what condition can we put here? Well, we can have while well, what will year be until they put something in? It will be an empty string, right? So while, we could say while year is an empty string, let's keep asking them for a year. And we can add other conditions. We can make sure that it's a number. We can do all kinds of things, right? But for right now, so what are we looking at? We're saying that the year is an empty string to begin with. And while it stays empty, let's ask them to enter a year. All right, so do you have this typed in? Are you typing this into something or are you just making notes?
Yeah.
Okay, let's run this. if you've created a file, save it as whatever, right? Whatever name you want. And let's run this. What happens? We're given a prompt that says, enter a year. What happens if we just hit enter and don't actually put a number in there? What's it do? Did you get an error? Check that everything is written exactly.
You might need to have the integer thing outside of the.
Yes, because it tries to convert it to an int and we get an error there, yes. Yes. Thank you, I got ahead of myself there. Move that back. We don't want to convert it to an integer until after they've actually given us something that can convert to an integer. Thank you. So what happens now?
It just keeps asking.
It keeps asking, enter a year. You hit enter without putting anything, it says enter a year. You hit enter again, it says enter a year. It's going to keep saying enter a year until, let's enter a year. Then it's going to go on, right? And we'll output something down below. Now what if you ran this, and when it said enter a year, you typed in your name? Try that and see what happens. We get an error, but the error is because of this. It can't turn your name into a number. All right, so again, we're not checking completely if they've typed in a valid thing. We're just checking to see if they've typed in something. So what happens with this while? While will check this condition. And it will check to see, is year empty? Is it an empty string? Well, it is right now the first time, so it will prompt us for a year. If we hit enter, without putting in anything, year is still empty, and so it comes back, checks the condition again, and prompts us again. And it will continue to prompt us until we put in something. Then this time it goes on and breaks if you put in something that's not a number, but that's a separate concern. What could we also do? We could also check to make sure that year was a number. We could also, as part of the condition, we could also check to make sure that it's a big enough number and have other conditions that we're trying to satisfy. Okay, so how many times will this loop execute? How many times will we get that prompt?
Until you type in a number.
Until we type in a number. We don't have any way of saying how many times that is. With a for loop, what happens? We have to predetermine how many times we're going to say something, right? With a for loop, it's counted. We know how many times it's going to take place. This loop might only happen once. Will it happen at least once?
Or if you enter a year.
Yeah, well, it will happen at least once because our condition has been preset to be able to be met at least once. But sometimes we will write while loops that, depending on what else came before, they might never kick in with that particular situation. So sometimes we'll have while loops that depend on what answer you've given before. So if you gave some answer before that doesn't satisfy whatever condition is here, then this loop might not happen at all. That time through the program. A different time through the program, it might happen a whole bunch of times. So a while loop gives us a different amount of control than just the for loops that we've seen before. The for loops are perfect for what we use them for. While loops are useful for something else. Okay, so there's two other aspects of the while loops that I want to talk about quickly. If you are in a loop, and there's some condition, whatever it is, you might get to a certain part of that loop, and you've satisfied some condition, and so you want the loop to end. So if you've satisfied some certain condition and you want the loop to end, you can use the word break to end the loop. It will stop right there and jump out of the loop. All right, so the word break will end a loop. Actually, you can use break inside of a for loop as well. It will break out of that loop. So if you were looking for someone to enter, say, you were playing a guessing game, and you were saying, guess the number. And they guessed the number, what do you want? You don't want to tell them to guess again. You want to jump out and say, hey, you won. And so a break will keep them from having to keep guessing. It will jump out of the loop. Sometimes you will be in a certain situation, and you get to a certain part of the loop, and you don't want to keep going in the loop. You want to send the person back to start over. So if you want to send the person back to start over, the word continue inside a loop, if that comes up, maybe you have some conditions or whatever, what continue will do is send back to the beginning of the loop and start over. So continue will send control, or the program itself, back to the beginning of the loop. So if we had some situation, we're updating a number. If you get to something where you don't want to count something, you get to that thing and you say continue before you update a count, it will send us back to the beginning without updating the count. So let's take a look at that. Let's say we have x equals 5, and we want to count how many odd numbers there are from 1 to 5. So we could say something like, while x is I'm going to do it in an odd way. While x is greater than or equal to 1, we're going to check each value and see whether it is an odd number. So we're just going to print out the odd numbers right now, right? Instead of counting, we're just going to print out the odd numbers. All right, so what's going to happen? We could, again, this isn't a good choice in this particular situation. I just want to show you how continue works. All right, so actually, this example probably isn't a good way to show how continue works, but we'll do it. All right, so if x, we want to see if x is odd, we want to print that. So what's going to happen? How do you check to see if a number is odd? We use the modulus. If x divided by 2,
Does not be. Or does be.
well, you can do it either way, right? If it does equal 1, then what does that mean? It's an odd number, so what will we do? We can print x. Actually, I'm not going to use continue. I'm just going to use this as a different kind of loop. We may have actually done this in the video from last night. What happens if we print that x now? What do we want to do? We want to consider the next x value. Which x value are we considering first? 5. So what is the next x value that we want to consider?
4.
We want to consider 4. So how do we make x be the next value.
X equals,
We do x minus 1.
Outside that, or inside that, but outside that, we could, let's experiment. Let's put this inside here. We want to make x equal to x minus 1. And I think we've mentioned the shortcut approach to x equals x minus 1. We can say minus equals 1. Now we're going to break something here, so we want to experiment and see what happens. All right. What happens if we run this? You can run it in the interactive shell, or you can write it into a program and run it from there. What happens if we run this?
Prints 5.
It prints 5 and what? All right, just prints 5 and does it end?
Well, it gives me a prompt to type something.
Does it give you a prompt to type something? So what has happened? X started off as 5. While x is greater than or equal to 1, so is x greater than or equal to 1?
Oh, let's just keep repeating.
It says, let's check that number to see if it is odd. Is it odd? Yes, so it prints 5, and now it makes x 4. And then it comes here to check to see is x greater than or equal to 1. Is x greater than or equal to 1? It's 4, and what happens? That doesn't happen, so what should happen? X is 4, so it checks to see if x is greater than or equal to 1.
It shouldn't print it.
We won't print 4, but all it does is check to see if x is greater than or equal to 4. Is x greater than or equal to 4?
Oh, so it doesn't do the minus 1.
It doesn't do the minus 1 that time. Is x greater than or equal to 4? Or excuse me, is x greater than or equal to 1? 4 is, so it checks again, and goes back and checks again, and again, and again, and again, and what should happen?
Should minus 1, but it doesn't.
minus 1 each time.
It doesn't minus 1, it'll just sit there, right? So what happens if we put the minus 1 inside here? Get the 5, prints out the 5, and then gets caught in an infinite loop. So what do we need to do? We want the minus 1 to be outside the if statement so that we'll print the odd values and then decrease by 1 and print the other values. Right, so 5 would print, 4 would not. 3 would print, 2 would not, 1 would print. Make sense? Okay, so what would happen if we put a break right here? Let's run this and see what we get.
Just prints 5.
Prints 5 and ends, right? Because 5 was odd, it printed 5, it ends. The break takes us out of the loop. What if we put the word continue right here? What would happen? What happens there?
Repeating the first step over and over again, every 5.
Okay, how do I-
Prints 5, 5, 5, 5, 5. It keeps on printing 5, right? Does it ever stop printing 5? No. Right? So what has happened? It gets to here and it says continue, which takes us back to the top of the loop. It never gets down to the part of subtracting 1. Now, sometimes you want to do that. Sometimes you do want to go back to the top of the loop when you get to a certain point. A lot of times you don't. But if you do want to go back, you've gotten to a certain point, you say, well, there's no reason to go further. Let's go back to the top. So continue will take you back to the top. How do you break out of this? Control C. If you're running this and the 5s are just printing and printing and printing, you can Control C, and that will break out of, right, the keyboard interrupt to break out of the loop. Okay, so this idea of being able to take input, do something with it, or to have a loop that you can continue with a while rather than a counted for loop. All right, so that sort of make sense? We're going to keep adding to what we do. We're going to have more adding little pieces along the way and be able to do better with the input. We're also going to be able to take input from the keyboard rather than just typing in something. We'll be able to use like the arrow keys and so on. We'll do that in the context of some game things. Be able to take input from the mouse in game context. But it's the same kind of idea, right? We're going to, it's slightly different in that particular situation rather than input, but it's the same exact idea. We're getting the input and then doing something with it, okay? So we want to make sure that we get the right kind of input. And so the right kind of input we can put into tests like we did here to make sure that the kind of input is valid. If we are playing a game that is in a screen, if we have a window, if somebody moves the mouse outside the window, we don't want that content to affect what's going on in the game. So we'll have tests. We'll have the same kind of thing of we're testing to make sure that the mouse is actually inside the frame. If it goes outside, we'll deal with that in a different way. So we'll reuse this kind of loop a lot. Okay, so we have some questions about the lab that's due, the second half of the lab. We probably have questions. If you've already finished that, some of you have already turned that one in, you can be working on the lab that's due next week. And so I will try to be around to answer as many questions as you possibly have. All right, so chapter 7 goes into a bit more information, some examples about the break and continue and so on, but that's the basic ideas. Break, we'll just stop the loop right where it is, jump to the end. Continue, wherever you are, we'll go back to the top of that loop and do it again. So there are times when you want to continue, times when you don't want to. Sometimes you just want the loop to go ahead and finish out and then go back to the top as needed, but sometimes you want to go back to the beginning sooner rather than later. All right, so